Let's just dive right in. We've all been there, right? You're staring at an integral, and your brain just stalls. Is this a substitution problem? Should I use integration by parts? It feels like you're just guessing. Well, today we are officially swapping that guesswork for a rock-solid strategy. Consider this the start of our detective training for choosing the right integration method every single time. So I want you to start thinking of yourself as a calculus detective. Seriously, every integral is a new case to be solved, and your job is to look for the clues that are hiding inside its structure. So let's grab our magnifying glass and get started. The first question we always need to ask is, what kind of mystery are we actually looking at here? Okay, so our very first lead in any investigation, our number one person of interest, is always going to be u-Substitution. It's the most common suspect, frankly. It shows up everywhere. And it's all about spotting one very specific pattern, a kind of hidden chain. Now, what's so cool about this is that it connects directly back to something you already know, differentiation. You remember the chain rule, right? Well, u-Substitution is literally just the chain rule running in reverse. We're on the hunt for a function that's inside another one, and somewhere nearby, its derivative is just hiding in plain sight. I like to think of this integral as a set of those Russian nesting dolls. You've got an outer function, that f, and then you have an inner function, the g of x, kind of tucked inside of it. The key clue, the real smoking gun, is that g prime of x piece, the derivative of the inside function just sitting right there next to it. When you see that perfect pairing, boom, you've basically cracked the case right open. So it all comes down to this really simple two-step process. First, you just look. Do you see a function tucked inside another one? You know, like e raised to the power of x squared? That's your nested function. Then comes the test. You ask yourself, okay, if I make that inner part, that x squared, my u, is its derivative, the du, also in the mix? Well, the derivative of x squared is 2x dx. So if you see an x hanging around nearby, that's your clue. That's the signal to go all in on u-sub. But what happens if you run that test and the clues just don't add up? What if that derivative is nowhere to be found? Well, that's when our investigation pivots. We don't just give up, we move on to our second lead suspect, integration by parts. And, just like u-sub was the reverse chain rule, integration by parts is the reverse product rule. This is the technique we go to when the integral looks less like a nested doll and more like two totally different functions just being multiplied together. Think something like x times cosine of x. And here's its famous formula. Now, the whole game here is to break our original integral into two pieces, a part we call u that we're going to differentiate and a part we call dv that we're going to integrate. The trick, and this is everything, is to choose them wisely so that the new integral on the right, that little integral v du part, is way, way simpler than the monster we started with. Now, this right here is my favorite detective tip. This is a real game changer. If you try u-Substitution and you're left with all these extra x terms that just won't cancel out, just stop. Don't try to force it. That is a massive, flashing, neon sign of a clue telling you to drop that line of inquiry and switch your whole strategy over to integration by parts. Okay, so you've made the call. It's an integration by parts case. Fantastic. But now comes the most critical decision of all. Which part is going to be your u? This is where every good detective needs a reliable informant. And in the world of calculus, our informant's name is LIATE. LIATE is your priority list. It's an acronym that tells you exactly what to pick for you. You just look at the two functions being multiplied, and you see which type shows up first on this list. L is for logarithmic, I is for inverse trig, A is for algebraic, things like x squared, T is for trig, and E is for exponential. The very first one you hit as you go down the list, that's your u. Simple as that. And this is the brilliant reason why it works so well. Remember, the whole point is to make our new integral simpler, right? Well, think about it. Functions at the top of this list, like a logarithm, get way simpler when you differentiate them. The natural log of x just becomes 1 over x. But functions way down at the bottom, like e to the x, they don't change at all. So LIATE guarantees you're picking the u that will simplify your problem the most. It's just so smart. All right, detective, we've gone deep on both of our main suspects. Now it's time to put their profiles up side by side. Let's look at the visual evidence so you can tell them apart in a lineup, no problem at all. So let's review the case files. Over here on the left, you've got u-Substitution. Its signature move, its MO, is the nested function. It's all about unwinding that chain rule. On the right, you've got integration by parts.
This guide deals with a product of two different kinds of functions, and it's all about unwinding the product rule. The key difference is visual. Are things inside other things, or are they sitting next to each other? That single question will almost always break the case wide open.
So we've gathered all the clues, we've profiled our suspects. Now let's put it all together into a master protocol, a step-by-step flowchart that you can use to crack any integration case that happens to land on your desk. Here it is. This is your game plan, your tactical approach. Step 1, always check for the easy stuff first. Can this be solved with a simple power rule? If not, move to step 2. Investigate for u-Substitution. Do you see that nested function and its derivative pair? If that lead goes cold, you proceed to step 3. Investigate integration by parts. Is it a product that fits what our informant, LIATE, told us? And only then, if all of that fails, do you bring out the heavy-duty last resorts. And that really brings us to the absolute core of this whole thing. Being a great calculus detective isn't really about memorizing a bunch of formulas. It's about training your eye to see the patterns, to identify the structure of the problem before you even start writing. It's all about using strategy instead of brute force.
And there you have it. You now have the strategic framework. You've got your detective kit, you know all the clues to look for, and you know the right questions to ask. So the next time you face one of those tough integrals, you won't be guessing. You'll be investigating. So my question to you is, what mysteries are you ready to go out and solve?